Pre-calculus. Today we're going to look at section 5.4 on how to apply trig functions. First slide is just making sure that you have learned the previous material. Just very quickly review. The first question you see is obviously a right triangle. Notice that I've given you a leg of 5 units and a hypotenuse of 13. If I put theta at this angle in this location, from that perspective, we know from the past that side marked 5 is the adjacent side. And we know that the 13, like I said before, is the hypotenuse. Because I do not know the angle theta, like the degree measure, this is not a special right triangle, but I did give you 2 lengths of the sides. So anytime it's a right triangle and you know 2 sides, obviously you're allowed to use Pythagorean theorem. So you can do a squared plus b squared equals c squared, put you a b here, for example, and solve it that way. Or if you know the triples, which I asked you to memorize 4 of those, then you recognize that this is a triple, and it is a 5, 12, 13 triangle. And so this side would be 12. So if you memorize the triples, that's a lot faster way to find the missing side. If I did ask you for the sine of theta, then your answer would be opposite over hypotenuse, which is 12/13. If I ask you for tangent of theta, you would do O over A. In this case, it would be 12 over 5, and so forth. So when we have right triangles and we know 2 lengths of the sides, we can find the third by using Pythagorean theorem or to see if it's a triple. The second type of triangles that we covered in the last unit or last section are special right triangles. So anytime I have a right triangle and I clearly can see that the acute angles are 45 degrees apiece, then I can use ratios to help me find the missing sides. Notice in my example 2, I only gave you the hypotenuse length, so using Pythagorean theorem, because I don't know these sides, would not even help me. So ratios would be the way to go here. Across from 45 is the 1x side. So the legs of this triangle have to be the same answer. And then the hypotenuse in this special right triangle is always x square root of 2 times longer. Since I gave you the hypotenuse length of 6, you would then take the ratio x radical 2, and you would set it equal to 6, and you would solve that equation for x. Once you go through the steps and you divide by radical 2, you're going to get x is equal to 6 divided by square root of 2. And we know, because we've worked on this type of problem several days now, that you can't leave a radical underneath the division bar, so you would have to rationalize. And to finish this up, you would just go multiply straight across and get 6 square root of 2 divided by the square root of 4, which is 2. And then you would notice that the 6/2, 6 divided by 2 reduces to 3. So the best answer for x is 3 radical 2. And once you found that answer, then you could go back and take this and substitute it in for your missing sides. So in my example 2, because it's a special right triangle, I use the special notation, the ratios, to find that x is 3 radical 2. Everything you've been taught in the last 3 sections in this trig unit has dealt with either right triangles or circle trig. We're going to continue moving forward, and this time what we're going to do is use trig to find missing sides of right triangles. Sometimes when you are given a triangle that's a right triangle, you either do not have enough information for the sides, like notice in this picture, I only gave you the hypotenuse length, and I gave you one of these angles at the bottom, and I marked it 40 degrees. And so you're going to put a degree mark there, and then you're going to use trig to find side E, which is the opposite here. Alright, so what you'll have to notice is that because I do not have 2 sides of the right triangle, then I can't use Pythagorean theorem. Also notice that the acute angle that's given to you is not a 30-60 or a 45-45. And so we're going to learn a third way to find the missing sides using trig. From your angle that I gave you, which is marked 40 degrees, the opposite side is labeled lowercase e. This is angle E. The side across from the 90-degree angle is marked 12. So to find the missing side, and also a good time to note this, remember from geometry when they use capital letters for angles. So if this is capital letter E, then the side opposite that, they always mark it with the lowercase e. At the top, this is angle C, capital C. So technically, we could call this side lowercase c. Again, that's geometry concepts, but it is important that you remember that because a lot of your problems are going to use variables. So capital letters are angles and lowercase letters are or will stand for lengths of sides. So let me get rid of this. And what we're looking for in my example 1 is just side marked E. Across, back to the 40 degrees, across from 40 degrees is the opposite side. 12 is the hypotenuse side. And so you're going to use your definitions like your SOHCAHTOA, and since opposite over hypotenuse is sine, then you would be able to choose sine to help you find this missing side. You're going to now use 40 degrees, because we already know how big that angle is. You're going to set up an equal sign, an equation. The opposite is going to be E. So I'm going to go ahead and put my E in here. And then my hypotenuse is going to be 12. So the sine of 40 degrees is equal to E divided by 12. From that, I will now have to solve for E. And to do that, I'm going to do the opposite of dividing by 12. So we're going to have to get rid of the 12 by multiplying both sides by 12. We'll put it on this side as well. And I would always get yourself in a habit of putting the trig expression in parentheses. So 12 times the sine of 40 degrees is equal to, the 12's cancel on the right, it's equal to E. And then you're going to make sure your calculator is in degree mode. Remember, your calculator can be in radians or degrees. So make sure it's in degree mode right now. And then you're just going to type in 12 times sine of 40. If you do have it in the correct mode and you've typed it in correctly, right now you should have gotten a decimal. I'm going to round to the nearest 100th, so I'm going to write 7.71. And because E stands for a side, I did not mark or give you units up here like inches or feet. I'm just going to put units on my answer. Okay, so 7.71 units is the length for side E. All right, question 2. Question 2, we notice, obviously it's a right triangle. I see angle B clearly marked. Again, capital letters for the angles and lowercase letters stand for the sides. I notice in this picture I have also have an acute angle of 58 degrees. Anytime they give me one acute angle, then obviously I can find the other one if I need to by using subtracting it from 180. So at 58 degrees from this perspective, this side would be opposite. This side is hypotenuse. And this side is adjacent. And so, again, because I only know one side, I can't use Pythagorean theorem. Because this is not 30, 60, or 45, I can't use special right triangle. So trig is the only way I'll be able to find the side marked A and B. And so when you have two sides that you're trying to find, I do need you in your practice set to make sure you're organized, and to label it for me so that way I know that your equation is actually matching the side you're trying to find. So I'm going to do this, and I want you to try to model the same way. So I'm looking for A right now. From the side or angle that's marked 58 degrees, again, this is opposite, but I want to choose the side that I know a number for. So obviously I want to choose the adjacent side as well. The trig definition that stands for O over A is tangent. So this time I'm going to need to use the tangent of that angle, 58 degrees. And then the definition again is opposite, so to put the opposite side on top, and that will be my variable A. And then the adjacent side is 20. And so if you'll use your definitions, you'll be able to set up the trig equation fairly easy. And then your goal is to solve for A. 20 is being divided by A, so you'll do the same thing we did on the last problem. You will multiply both sides by that number. Again, remember to put your tangent or your trig expression in parentheses. The 20s cancel on the right side. You're left with A equals, and then you're going to type in 20 times tangent of 58 degrees. I would use parentheses around the tangent part for sure. And I'm getting 32.01. Just trying to keep it consistent with my last answer. I'm rounding to the nearest 100. And I would use units on my answer. Okay, so I've found the missing side for number 1. The only one I had to find was E. In question 2, I'm looking for two sides, so I've only done A so far. Alright, so next I would go and label my next part. I'm looking for B right now. To find side B, I need to use the side that they gave me, adjacent, and then B, which is hypotenuse. I actually could put 32.01 back up here and use that side if I wanted to, but I've rounded it, so it will affect my answer just a little bit. So I always prefer to use the number that they give me. So again, I'm using the adjacent hypotenuse definition. A over H is cosine, so that way I'll have to use, that's how I know to use cosine to find side B. And so you'll do cosine of 58 degrees is equal to, and remember the definition is A over H. Well, the adjacent side is actually 20, and the hypotenuse is the side I'm trying to find. So this equation looks different because of just the nature of where the variable is. To find side B, I can't solve the equation with the variable underneath. So what I'm going to have to do is multiply both sides by B. I've got to get the variable I'm solving for off the bottom. That leaves me with 20 on the right side. I'm going to recopy what I see on the left side. And now, again, I'm still trying to get B by itself, and B is now being multiplied by this trig expression. So I'm going to need to divide both sides by cosine of 58 degrees. And so because, again, the variable was underneath the division bar, you can't solve an equation with it in that format, so you're going to have to multiply both sides and then divide through by the trig expression. Cosine 58's cancel, and so now you have B equals, and you will enter this into your calculator. And again, make sure it's in degree mode. 20 divided by parentheses, always use parentheses, cosine, and then 58 degrees. And if you did enter that correctly, you will get 37.74. And that is units. Okay. So there's my two missing sides. This side's 32.01, and this side is 37.74. 37 is obviously bigger than this, and I would hope it would be, because obviously that's the hypotenuse, and remember the hypotenuse has to be bigger, longer than the other sides. Okay, so again, that's just using trig equations to help you find missing sides of right triangles. So that's really pretty much learning target 1. Alright, quick note, on questions that give you, sometimes you'll see angles marked with degrees and minutes. Remember that we have been taught how to convert those, and so like when you do see 75 degrees and 14 minutes, I need you to go ahead and convert it back to just degrees. And so remember, you're going to do 14 times 60. And then, 14 divided by 60, and you're going to get 75.23 repeating. So I'm just going to do 23 and put my little degree mark on that. So 75.23 degrees is what you'll use in your trig equation. And again, so we're looking for sides labeled C. It's opposite the angle that I am given. The side I noticed that they gave me is 8. And with respect to this angle, it is the adjacent side. That's how you have to think about it. So always look at the angle they give you in the right triangle, that's acute. And from that angle's perspective, start labeling your sides. And that way you don't make a mistake on the position. It's opposite over adjacent, and the trig definition for that is tangent. So you would do tangent of 75.23 degrees is equal to C divided by 8. And then you'll multiply both sides by 8. You'll put parentheses around this part. You'll drop your C down, and then you'll just multiply. Let's see what happens there. And I'm getting, let's see, I'm getting 30.34. And that is units, because we're talking about sides. And again, I'm rounding. Okay, so my answer is the rounded version. So this is the length of that side. Now, if I were asked to figure out what this side is, let me try that again. If I were asked to figure out what the hypotenuse is, I would either have to substitute this in for C and maybe use Pythagorean theorem. That's an option you have. Or, now that answer might be a little bit off because, again, I've rounded it. Or you can just go back and from this perspective, use adjacent over hypotenuse. And using a trig equation would be a more accurate answer, to be honest. So that would be A over H. You could do cosine of 75.23 degrees is equal to 8 over X, and then solve the equation that way. So just pay attention to how many sides you're actually asked to find. If you are asked to find 2, like I did in question 2, please make sure so there's no discrepancy and so I don't grade your problems wrong. Please, in your practice set, label, like, I'm finding side A now, I'm finding side B. Make it very clear what work goes with what side. Okay, let's take a look at a word problem. The chairlift at a ski resort rises at an angle of 20.75 degrees, and it attains a vertical height of 1,200 feet. How far does the chairlift travel up the side of the mountain? The chairlift at a ski resort rises at an angle of 20.75 degrees, and it attains a vertical height of 1,200 feet. So we've got an angle that's rising. We've got a vertical height of 1,200 feet. How far does the chairlift travel up the side of the mountain? And so what we want to do is create a picture. Alright, so we've got this chairlift. Okay, there's my seat. And it is rising at a 20.75 degree angle. It's obtaining a vertical height of 1,200 feet. It's going to create a right triangle for us. Vertical height, so this is 1,200. Make sure you use your units. And the angle is rising 20.75. And so you want to make sure you put the angle in that position. If you put it up here, you're telling me the chairlift's already at the top of the mountain. So be careful, because the way you draw your picture is extremely important. Drawing it incorrectly will definitely give you the wrong answer. So it does say the chairlift at a ski resort rises, so it's on the ground. It's moving up the side of the mountain. The question is, how far does the chairlift travel? So we're looking for this distance. Okay, we're not looking at the distance between the chair and the ground here. We're looking how far does it travel up the side of the mountain. Alright, so this is the angle that we're going to use. Across from it, opposite, is 1,200. So this would be the O, or opposite side. And what we're asked to find is actually in this picture the hypotenuse. And so the definition for O over H is going to be sine. So we're going to do sine of 20.75 is equal to 1,200, opposite on top, divided by hypotenuse, which is what we're trying to find, and there's your x. And let me mark my degrees here. And so this is the trig equation I'm going to use to help me find the distance. To solve for x, you do what we did earlier. You're going to have to get the variable off the bottom, so multiply it by both sides. X's cancel. Then you're going to find x, you're going to divide both sides by the trig expression. And then you're set. Okay, so x equals, and use your calculator, it's supposed to be degrees here. 1,200 divided by parentheses, sine, 20.75. It's measured in feet. So I'm getting 3,387.05 and then feet. And again, notice that x is on the hypotenuse side, so it should make sense to me that the answer is obviously bigger than the opposite side. 3,387.05 feet. Okay, we're going to move to part 2, and that is on angles of elevation and depression. You should have done a little bit of this in geometry, but just reminding you, if we're referring to an angle of elevation, which is actually what I did on my previous problem, and the chairlift is on the ground, I'm elevating it upward, I'm looking upward, that would be called an angle of elevation. And so it basically just means that you're looking up, okay? The formal definition is an angle formed between a horizontal line and a line of sight from an observer to an object at a higher level. Basically, I'm standing here, if my eyes are looking like straight ahead, and then I'll suddenly see something in the sky, maybe a hot air balloon or a plane or something. When I look up, that angle that I've created by looking straight ahead and up is an angle of elevation. Angle of depression is the opposite. It's as if like somebody, let's say we have a hot air balloon and somebody's in the hot air balloon and sees me on the ground. Well, first they're going to look, straight across. That's their horizontal line of sight. And then when they look down and see the person on the ground, that's creating this angle, which is an angle of depression. So again, those are formal definitions on your screen. But remember it that way. Elevate means up, and depression is actually looking down. Okay. All right. Topic 3, which is our next learning target, is using trig to find missing angles of right triangles. So we've already done missing sides. Now we're going to look at how to do missing angles. If you're missing an angle, you would definitely want to pay attention to where your variables placed. Notice in my pictures 1 and 2, I've got x inside and then y inside. Those are definitely angle measurements. And so when you're looking for an angle, you don't just use sine, cosine, tangent, cosecant, secant, and cotangent. You use the inverse functions, and these are on your calculator. If you have an 84, it's the like right above the sine key would be the sine inverse. Right above the cosine would be the cosine inverse, and so on. Alright, so for example 1, we have triangle ABC. Notice that side AB is marked 12 centimeters, side BC is marked 18 centimeters, and the variable is actually on the inside, which means I'm finding the answer for angle C. So you're going to start with x. Okay, from this perspective, 12 would be the opposite because it's across from it. The 18 is actually in the position that's adjacent. So opposite over adjacent. We know that this is the hypotenuse. But in order for me to find the angle, what you're going to want to do is try to use the sides that the problem gives you. So O over A. Okay, so we're going to use tangent, opposite over adjacent. Tangent of what? Well, what angle is it? We don't know. We're trying to find it. So you're going to put your x there, equals, again, always go by your definition. That's all we're doing. Opposite goes on top, so that would be 12. Adjacent goes on the bottom, that would be 18. So the tangent of some angle is equal to this answer. What you want to do next, you cannot solve a trig equation when the variable is beside of the trig expression, because this stands for an angle. You cannot solve for x by dividing by tangent. I've had people that's tried to do that in the past. Okay, so what you're going to need to do is you're going to isolate your variable, and you're going to use the inverse tangent. So just watch the notation and make sure that you write it this way, because I am going to be picky about looking for that. So the first thing you'll do is write it down like I did. Then to get x by itself, you'll write x equals, you'll use the tangent inverse notation, so you'll write it like that. And then I always like parentheses here, and then I'll just copy down that fraction. If you want to reduce that fraction, you also can do that. It will work either way, because I know that does reduce. So we're going to type in inverse tangent. Remember to hit the second key in the tangent button, and then 12 divided by 18. I want the answers in degrees, so I'm getting 33.69 degrees. And so you also have to be aware of, obviously, what types of answers you're supposed to be giving. So because we're talking about an angle, it's on the inside of the triangle, make sure you use your degree mark on your answer. Okay, we'll try that one more time. For example 2, notice that I have triangle DEF. Angle E is the right angle, of course. I do know all 3 sides, 7, 24, 25. This is a triple. The variable is located inside the triangle, so we're looking for the measurement of angle F, which is labeled Y. So we're trying to find Y right now. Okay. Because it's an angle, we have to use an inverse function. And now that we have all 3 sides, from angle Y's perspective, we can label all 3, but we can choose which one we want to use. So from Y, this would be opposite. 7 would be the adjacent side. Again, you're looking from the Y. And then 25 would be the hypotenuse. And so I'm going to show you, you actually can pick any of these 3 definitions. Let's choose sine this time. So I'm going to do opposite over hypotenuse. And so the way I'm going to set it up is sine of angle Y can be found or is equal to the ratio of 24 opposite over hypotenuse, which is 25. Sine of Y equals 24 25ths. Again, show the next step in all your practice problems. To get Y by itself, in this scenario, you have to do the sine inverse notation, and then just drop your fraction down, use your calculator, and you'll be done. Okay, so Y is equal to, second sine is sine inverse, 24 divided by 25, and I'm getting 73.74 degrees. 73.74 degrees is the measurement of the angle that's marked Y. So if this is 73.74 degrees, and let's just say they asked me to find the other angle, then I can either put a variable here and set up another trig equation and find it that way, or I can just know that from geometry, obviously all triangles add up to 180, so I can take this answer, add it to 90, and then subtract the 2 from 180 to get the missing angle. That's probably going to be a lot faster also. And then I did tell you I would show you why the other ones work. So look, we're going to pick another one. I'm going to do cosine for the same exact problem. I already know what the answer is going to be. But the cosine of Y, you would say, is adjacent. Well, adjacent 7 over hypotenuse is 25. So even though the equation, the trig equation, looks entirely different, the outcome will or should be the same. So Y is equal to cosine inverse. And now type that into your calculator. So cosine inverse of 7 divided by 25. And the answer is going to be 73.74 degrees. 73.74 degrees. Obviously, the same thing. So again, when they give you all three sides and you're trying to find an angle, that's entirely up to you which trig ratio or trig function you want to use. Just remember, if you're finding angles, you use the inverse. And then when you're finding sides, you just use the basic ones. Okay, so that's your learning targets for section 5.4. As long as we know how to do those things, we should be in good shape for this section.